Hello, everyone, and welcome to our third episode of Math Past Year Papers on ZNotes Live. I'm your host, Yukan. I'm here with Devandhira, and today we will start with the AS Pure 1 paper, Variant 2 from the May-June 2020 exam. If you guys want, you can also later check out the IG Ad Math paper that we did, because the syllabuses are pretty similar. On to you, Devan.
All right, so thank you, Yugan, and welcome back in our series. Well, this time we'll be doing AS Pure Maths 1. And before we start, I'd like to say that when you'll be doing the exam, you'll be given this formula sheet, and it has everything, almost everything that you need to know, so that you don't really have to memorize, or maybe say you forgot something. It even includes further maths and our normal maths, statistics, and mechanics, everything. All right, but we'll be using this later when we'll do the questions, and so let's get right into it. Straight to the first question. Find the coefficient of x squared in the expansion of x minus 2 over x power 6. So in this question, we'll be using the binomial theorem, binomial series, correct?
Mm-hmm.
So let's remember what the binomial series is. So this is where the formula sheet comes in handy if you forget, because it's just right here. Yep, it's just right there, and you can see what the binomial theorem is. So as you can see from the binomial, the first term is n choose 0. This is n choose 0 right here, which is 1, and it raises the first term in the binomial to the power of n. Well, whatever the power n is. In our case, it's 6. That means if you want to find x squared right here, we need to multiply these two terms with their corresponding powers, such that when you multiply them, it becomes an x squared. Is that right, Yugen?
Mm-hmm.
So how would you do that? Where do we start?
So in this case, we can notice that because the power of 6, we can raise x to the fourth power, and then we have the b term, our negative 2 over x, would be raised to the second power. Then we would have x to the fourth over x squared, which would
Exactly.
give us x squared.
So we'll have x to the power of 4 multiplied by negative 2 over x to the power of 2. But are we missing something here? I feel like we're missing something.
Yeah, the n choose 4 at the front.
Exactly. So because we have a raised to the power of 6, we have a 6 in here, and we have a 4 x to the power of 4, so we'll be putting 4. Though if you put 6 choose 2, it's gonna give the same answer. So even if you write 6 choose 2 here, it's just the same. So it's really your choice. But right now, we got what we wanted. Now we'll just have to simplify it. So what's 6 choose 4, Yugen? Is it 15?
6 choose 4 is, yeah, it's 15.
So it's 15 x to the power of 4 multiplied by 4 over x squared. All right, we'll have 15 times 4, that is 60. So as you can see right here, the x squared and x power 4 will cancel, and the x power 4 will be left with a 2 instead. And that's what we're looking for. We need to find the coefficient of x squared. So we have 60x squared at the end.
Mm-hmm.
So right now we just have to write the coefficient is 60, and that's our answer. Is that right, Egan?
Yep.
Exactly.
Just to add, if any of you students are a bit unsure about finding coefficients of specific powers, you can just list out the binomial up until you notice that it gives an x square or a whatever term that they're asking for.
That's correct. If you're unsure, then that's the best thing that you can do to get those marks. All right, next question. Find the coefficient of x squared in the expansion of this expression right here. All right. So as you notice that this part is what we've looked before from the previous question, except that it's multiplied by a new expression 2 plus 3x squared. We are told to find the coefficient of x squared. So what can we do here?
So we can notice that 2 multiplied by an x squared term in this binomial would give us an x squared term, and the 3x squared multiplied by 1 over x squared, 1 over the 3x squared multiplied by a constant term would give us another x squared term. So you have to add those two together.
Exactly. But we found the x squared term from the previous question, right? Which is 60 x squared. So that means we just have to look for the constant term coming from this guy. All right, so let's do that. We'll find the constant term. So because we want a constant term, the x's has to cancel. Therefore, as you can see here, if we have x to the power of 3 multiplied by negative 2 over x power 3, let me write it now. X power 3 multiplied by negative 2 x 3. You see the x cubed will cancel, right? But don't forget that we also have to put the choose here. The combination 6 choose 3. So this is our constant term. So can you help me? 6 choose 3.
6 choose 3 is 20.
20 x cubed negative 8 x cubed. This is 160, negative 160.
Yeah.
Correct? Yeah. All right. So this is our constant term, negative 160. Now let's just write the multiplication again. We have 60x squared minus 160. Though there should be more terms, but we don't really care about that. I'll just put a plus here, plus and so on, so on, so on. All right. We only care about the x squared term. That means all we need to do is just to multiply the correct terms so that I get an x squared. So I can see that when I multiply 2 times 60, I'll get 120x squared. Is that right?
Devan, you're cutting out.
Oh, sorry. So am I clear now? Is it okay? Okay. So I can see that when I multiply 2 and 60x squared, I'll get 120x squared. Anything else, Yukan? What's next? Yukan, am I lagging? Am I lagging, Yukan?
Devan, are you there?
Yes. Hello?
Yeah, you're lagging.
Oh, I'm lagging. Oh, that's weird.
Your camera's frozen. I can't see anything being done to the stream.
Oh, let me just rejoin.
Your voice is fine, but your video is frozen.
Oh, okay. So I'll just rejoin. I'll be back.
All right, we'll be back shortly.
All right, let me try.
Welcome back, Devan.
Hello. Can you see now? Is it okay?
Yeah. The stream is fine now.
Okay. So when I multiply 2 times 60x squared, well, I get 120x squared. So the next thing is I can multiply 3x squared and negative 160. Is that right?
And
I'll get multiplying negative 160 times 3 is negative
pop up, Devan.
480x squared. Do we need to multiply 2 times negative 160, Yugan?
2 times, no, that just gives a constant term.
Exactly, and we don't want that at all. So we just have to multiply the necessary terms that would give us x squared. So we can simplify this 120 minus 480, that's negative 360 x squared. And there you have it. We have the coefficient. Coefficient is negative 360. Don't forget to box it out. All right, let's move on. Express the equation 3 cos theta is equal to 8 tan theta as a quadratic equation in sine theta. Sure, why not? Let's write down first the original equation. So what I would do here is that I would change the tan theta into sine theta over cos theta. So 3 cos theta, I'll put it down here, is 8 sine theta over cosine theta. And we'll have to multiply both sides by cosine square. So not cosine, sorry, by cosine. So we'll have a cosine square here because cos times cos is cos square. I'm sorry about that. Is equal to 8 sine theta because cos theta here got cancelled. All right, what next? I got cos square and I got sine theta. What next you get?
You can use the Pythagorean identity to expand cos square into 1 minus sine square.
Exactly. So let's recall that the identity is sine squared theta plus cosine squared theta is equal to 1. I just have to make cosine squared the subject by moving sine squared to the other side, and I can just replace it. So we have 3 times 1 minus sine squared theta is equal to 8 sine theta. Okay. Then just expand everything and move it to one side.
Devan, okay, it's back.
Oh, it's back. Oh, am I lagging on this time? That's weird. I'm sorry about that. You just have to simplify, move everything to one
Slightly.
side. We'll have 3 sine square theta plus 8 sine theta minus 3. Is that right?
Mm-hmm.
All right. Then we'll.
Yeah, that's correct.
All right. We just have to box the answer. Is my voice choppy?
No. Also,
is my voice clear?
To our viewers, that sine square plus cos square equals 1. That's in your formula booklet. No, it's not choppy, Devan.
Oh, okay. Thank you. Ooh. All right. And let's go for the next question. Hence, find the acute angle in degrees for which 3 cos theta is equal to 8 tan theta. So this is just a follow-up question, which has the same expression. So that means we can just use this to find our theta, right?
Mm-hmm.
So let's do that. We'll just rewrite the equation: 3 sine square theta, so on. Make sure not to forget anything. And also, it says acute angle. Acute means the angle has to be between 0 and 90 degrees, right?
Mm-hmm.
All right. So let's solve this. It's a quadratic. Can we factor it?
Yeah. You can factor it into 3 sine theta minus 1.
Okay.
And sine theta plus 3.
Plus 3 is equal to 0. So for those of you who don't really know how to factorize this, you can always use the quadratic formula. Okay? Now, we have two equations that we have to equate to 0. Minus 1 is equal to 0, and sine theta plus 3 is equal to 0. And let's make sine theta the subject here. So we have the first one, sine theta is 1/3, and sine theta is negative 3. Now remember that sine theta can only go from negative 1 to 1. That's its range. Therefore, the second equation is impossible. Sine theta can never reach negative 3 at all. So we have to reject it. That means we just have to solve the first one. All right, just take the sine inverse of both sides. Sine inverse, we have sine inverse of 1/3. Can you help me with this one?
It's 19.5.
So 19.5 degrees. And that's our answer. We would do 180 minus sine inverse of this angle, but because it's only acute, we just have to take the alpha, nearest angle to the origin. All right, so don't forget to box your answers, and let's move on. All right, next one. A weather balloon in the shape of a sphere is being inflated by a pump. the volume of the balloon is increasing at a constant rate of 600 centimeter cube per second. The balloon was empty at the start of pumping. Find the radius of the balloon after 30 seconds. All right, sure. So the volume of the balloon is increasing at a constant rate of 600 centimeter cube per second. Okay. So before we do this question, we need to know the volume of a sphere, right? Because the balloon is the shape of a sphere. That means we have to look for the volume of a sphere. So if you don't remember, of course, there's always right here in the formula sheet. I didn't even know that it was here actually. I just realized it like 2 days ago. But whatever. All right, let's write it down. V to the fourth third pi r cubed. Right. So because it increases by 600 centimeter cube per second, after 30 seconds, you just have to multiply it by 30, right? We'll have, that means after 30 seconds, we'll have 30 times 600 centimeter cube. Can you help me with this? I can't calculate.
18,000.
18,000. Okay. So we have 18,000. And we're asked to look for the radius. That means we have to equate the volume of the sphere. Right. We just have to make R the subject here. Divide both sides by 4/3 and pi. We have R cubed 18,000 over 4/3 pi. Then take the cube root of both sides. We'll get this expression. Very scary looking one, but it's okay. Your calculator is your best friend. Can you help?
And that's 16.3.
16.3 centimeters. All right.
Mm-hmm.
That's our answer. Is that our final answer?
Yeah.
All right. Good to know. Easy to mark. Next one. Find the rate of increase of the radius after 30 seconds. Rate of increase. This means that we have to use derivatives, right? ddx, ddt.
Yep.
All right. Now, from the question, we're given that the rate of increase of the volume is 600. How do we write it in mathematical terms?
Rate of the increase of volume, so that's dv dt.
Exactly. So we have our first information, dv dt is 600. What we're looking for is dr dt, correct? Rate of increase of the radius. So dr dt. What we are looking for, dr dt. We don't know what that is. But using the chain rule, there has to be a relation, correct?
Mm-hmm.
There has to be a relation. So dr dt has to equal something times dv dt. That means this should be dr dv, correct? Because the dv will cancel here and you'll left be with dr dt. All right. We know what dv dt is, which is 600. But what's dr dv? How can we get dr dv?
We have the volume formula, so we can differentiate that.
Exactly. So we have our sphere volume formula, 4/3 pi r cubed. We can differentiate that with respect to r. dv dr is equal to, coincidentally, the surface area of a sphere, or pi r square. It's not really a coincidence, but we're not going to talk about that now. Oh well. So we have dv dr. If you're going to find dr dv, you just have to flip it. That means dr dv is just 1 over 4 pi r squared.
Pop up.
Oh, sorry about that. dr dt. Let's put everything in now. 4 pi r squared multiplied by 600. All right. It says that the increase of the radius after 30 seconds. Where can we put the second here? There's no time. There's only radius.
So we have our radius from part A. We can just use that.
Exactly. So the point is that 16.3 is the radius after 30 seconds. So you can express this dr dt in terms of r instead of t. So that's the trick here. So we have dr dt is equal to 600 over 4 pi 16.3 in the last answer that we got. That's 2 plus 3 squared. All right, can you help me with this?
And that would be 0.181.
181 centimeter per second, right? All right.
Mm-hmm.
Is that our final answer?
Yeah, that's our
All
final
right.
answer.
Don't forget to box it. And we're done. Easy 5 marks. Next one.
Mm.
The nth term of an arithmetic progression is half times 3n minus 15. Find the value of n for which the sum of the first n terms is 84. All right. Our nth term is half 3n. Oh, sorry, minus 15. We want to find Sn when it's 84.
Mm.
This would be much easier if we know what the a and d is, our first term and the common difference, correct?
Mm-hmm.
So let's do that. How do we find our first term?
We know that U1 is just A, so we can try that.
Yeah, that makes sense. So we like u1. That means half times 3 minus 15. Half, not 1/3, sorry. 3 minus 15. What's that? That's negative 6?
Mm-hmm.
All right, so it's negative 6. That's our a. What about the common difference?
So our second term would just be A plus D, and we have
Mhm.
already found our A, so we can just equate the sum formula and A plus D.
Exactly. So when we look for d, we can use u2, right? The second term.
Mm-hmm.
With when we have that, we'll have half 6 minus 15. Can't calculate that. Negative 9 by 2. Is it?
Mm-hmm.
Is it negative? Okay. So in order to get RD, that means RD has to be U2 minus U1, correct? That is negative
Yeah.
9 by 2 minus negative 6. 6 plus 6 minus 9 by 2. What's that?
So that's negative 9 over 2 plus 12 over 2, which is 3 over 2.
3 over 2. All
Or
right.
1.
So we have our A. This is our A right here. And this is our D. Now let's recall the sum formula. The sum formula says that, I don't really remember honestly, but thank God for the formula sheet. Thank you. We have the sum formula right here. And it's best that we would be using this one because we know the first term and the second term. The A here is the first term, D is the common difference. All right.
Mm.
So half n 2a plus n minus 1d. All right. Let me write that down. Half n 2a plus n minus 1d. All right. Now, and because we want this to be equal to 84, we just have to equate it to 84. And let's put everything we know into the equation. So half n, we're looking for n, to a, which is negative 6 here, negative 6, plus n minus 1, 3 over 2 is equal to 84, right? Okay, so let's solve this. Let's simplify. We'll get half n, we'll get negative 12 plus 3 over 2n minus 3 over 2 is 84. We can. Do you want to multiply 2 both sides? I think that's better. And
Yeah, we can multiply by 4 if we factor out the half.
yeah, that makes sense. Multiply
Wait,
by 4.
minus
So
12 minus 3 over 2 is negative 27 over 2.
sorry.
So the two constant terms added together.
Oh, you mean this one?
Yeah,
Okay. What do they become?
negative 27 over 2.
27 over 2. Okay. I guess we can multiply both sides by 4 here. So that I can cancel the 2 like that. So we have n negative 27 plus 3n. What's 84 times 4? I can't calculate that. That's so hard.
336.
336. Thank you. Okay, even divide by 3, yeah. So we have negative 27 n plus 3.
Oh yeah, you can.
236. I'll divide by 3 because it'll be easier. N squared. 37 divided by 3 is 9, and it's equal to 112. Move everything to one side, and let's solve the quadratic. I need help here.
Okay, give me a sec.
Sure.
That should you can factor it into n minus 16
Mm-hmm.
and n plus 7.
N plus 7 is equal to 0. Alright, so that means we have two values of n. N is equal to 16, or n is equal to negative 7. But because n is only for positive, we don't care about the negative 7. It's impossible, right? Alright, that means we just have to box our answer, which is 16. Easy 5 marks. Well, so many lines, but it's okay. Right, next question. The function f is defined for x in real numbers by fx is equal to a minus 2x, where a is just a constant. Express f of x basically, and f inverse of x in terms of a and x. 4 marks. That's a lot. All right. It should be so hard, right? So let's find f of x first. This basically means that you have to put fx in itself, or I can just put a bracket here. Maybe that makes more sense. So we have a minus 2 multiplied by fx again, which is a minus 2x, right? All right. Then we can simplify this. A minus 2a plus 4x. That's just 4x minus a. Okay. That's simple, right? Now let's find f inverse. So in order to find f inverse, we'll have to my method at least, I would change fx into y. Just make it into y first. A minus 2x. This should have been f of x, but I changed it to y. After that, I would swap y and x. Like literally just swap it. And after this is done, make y the subject. So let's make y the subject here. So we can bring it here, and this one here. 2y is a minus x. Y is equal to a minus x over 2. And once we're done, we can state that this is f inverse of x. And we're done. Though you kind of, I think you can do this quicker, right? What's your method?
Yeah, you can just swap your f of x and x straight away. You don't have to use y. And also, to those of you confused as to why we're swapping y and x or f of x and x, it's because the inverse is flipped on the line y equals to x. So you have to flip both of them in order to solve for your equation.
Exactly. So this is what you would do, right? This part here.
Yeah.
Yeah, but both are the same. Anyways, it's really your preference, honestly. But let's just box our answers. Don't forget about that. Haha. Next one. Given that f of x is equal to f inverse x, find x in terms of a. Yeah, sure, why not? So we found both. We have 4x minus a equated to a minus x over 2.
Your voice is choppy, David.
Oh, sorry. Is it clear now? Is it clear? Is it okay?
David?
Yes. Hello.
A bit, but your camera's still frozen.
Okay, I'll just reconnect.
All right, we'll be back shortly.
Hi guys.
Oh yeah, that's better.
Hello. All right. So as the question said, we just have to equate them and find what x is. So let's multiply to both sides here. 8x minus 2a is equal to a minus x. Move everything to one side, every x to one side, and every a to one side. We have 9x is equal to 3a. Agree? And that's it. We just have to divide by 9. So x is equal to 1/3 of 8. 3 divided by 9 is just 1/3. So that's it. And we're done. Okay? Right. Next one.
Your
The
stream
equation
is
of a
frozen
curve.
again.
Oh, sorry. What is frozen?
Devan? Okay.
Yes, yes. Hello.
It's back. It's back.
Is it okay? Hello, hello.
No, your stream was frozen for a bit. It's back. It's back. It's back.
What up now?
Yeah, yeah. You're
Okay.
fine.
Oh, God. All right. Next question. The equation of of a curve is y is equal to 2x squared plus kx plus k minus 1, where k is just a constant. Given that the line y is equal to 2x plus 3 is a tangent to the curve, find the value of k. So in this kind of questions where you have to look for what's the value of k, what's the range of value of k, what possible values of k, you would use the discriminant usually. And yeah, in this question we would be using the discriminant. Let's see if it's here. Is discriminant here?
No, it's part
I don't
of
think it's in
the
the formula
quadratic
sheet.
formula.
Yeah, I mean it's just in the quadratic
The
formula.
quadratic formula is in the first page. You can just take it from there.
Yeah, it's just right there. This is what you call the discriminant right here. Let me just write it down. People like to write it as a triangle. I don't know why. I'm just gonna follow it. So let's remember what the discriminant does. The discriminant tells us about
the roots of a quadratic.
Exactly. So if there are no roots, which means that the discriminant is less than 0, right? If there's one root, they'll be equal to 0. And when it's greater, not greater. When there are two roots, they'll be greater than 0. Basically, this is basically 0, 1, 2 roots. Okay, I'll just put it here. Oh god. So because that the line is a tangent, that means there's only one root. It only meets once. Wait, sorry. Okay. Wait for a while. Let me think for a while for this one. See if there's another more efficient way. No, I think it's best to use this one. Yeah. Okay, sure. Why not? Right. So let's do that. So let's equate these two first together. 2x plus 3 is equal to 2x squared plus kx plus k minus 1. It only meets once. Okay. We'll make everything to one side first. Plus k minus 2x plus k minus 4. This is the time where you use the discriminant. So we have our let me just write a, b, c right here. So we have k minus 2 squared minus 4, 2 minus 4. Because we only want one root equated to 0. Okay. Oh, I barely have any more space. I'm sorry about that. Right, let's just simplify this. So we have k squared minus k is 4 minus 8k plus 8 times 4, 32. Is it? Am I right? This is okay. This is right?
Yeah.
Okay. Now just simplify everything. K squared minus 4 minus 8. That'll be 12 plus 36. 9 and 4. I can factorize this in my head. K minus 9 and k minus 4 is equal to 0. I just put that out right here.
No.
Sorry?
No, that's not how you factor it. I'll give you another shot if you.
Is it not?
Try.
Wait,
try and expand it and see what you get. You won't get the same thing.
Oh my god. Oh god. Thank you for being here with me. 4 and 3, 9 and 4. And 4. Oh yeah, it doesn't. What?
It is k minus 6 squared.
K. Oh yeah. Oh god, I'm so sorry, guys. Anyways, this is so easy already. We can just score root both sides, and we have k minus 6 is equal to 0.
Mm-hmm.
And we'll have k is equal to 6. And that's it. I'm sorry for the mistake. Thanks, Yugan, for being with me.
It's okay.
I would have died if you're not here. Alright. It is now given that k is equal to 2. Express the equation of the curve in the form of this form, where a and b are constants, and hence state the coordinates of the vertex of the curve. Sure, why not? So let's do that. Just let k equal to 2x squared plus 2 kx, right? That means it's 2x plus 1. Right. We just have to make it in this form. This is called the complete square form. So I'll show you how to do it. First, we need to factor out the 2 here. We don't want any coefficient in the x squared. So we have 2 of x squared plus x plus 1. You don't have to factorize the 1. It's okay. It's quite laggy. Right. What's next? Next, oh sorry. We'll have to. So notice that the coefficient of x is just 1. I will have to divide 2 on that. So I'll tell you why. So x plus the coefficient that we divide by 2, which is half, squared, minus half squared, which is 1 over 4. This is called the complete square form. And the point is that when you expand this part, you'll be getting x squared plus x plus 1 over 4. Am I right?
Mm-hmm.
And but the thing is, we don't have a plus 1/4 in here. There's no plus 1 over 4 here. We don't have a plus 1 over 4 here, right? That's why we have to negative you have to subtract it. And yeah, then let's continue. And we can simplify everything, just expand it to 2x plus half squared minus half plus 1. Minus half plus 1, that's just plus half. So plus half. Right. Now that we already have it in the form, we have to look for the vertex of the curve. So if you remember what a vertex means, this is a quadratic, so the vertex will be at is the minima or the maxima. Minimum or maximum. In this case, it's a minimum because the coefficient of the x squared is positive. Agree?
Yep.
Okay. That means it can only occur when x is negative half. Why? When you put negative half here, this part will be 0. If you put anything other than negative half, you will not get 0. You will get something greater than 0. And when x is negative half, y is just half. 1 over 2. Half. Therefore, the coordinates is just negative half, comma, 1 over 2. Agree? All right. Easy.
That's
3
your
mark.
coordinate.
Anything you want to add?
No, there's nothing more to add.
Okay, let's move on then.
But just.
Yeah?
Actually, no, nothing.
Nothing.
Just continue.
You sure? Nothing? You sure?
I'm sure.
Okay.
You move on to question 7.
Right. Next question. In the diagram, OAB is a sector of a circle with a center O and radius 2r, and the angle AOB is pi over 6 radians. The point C is the midpoint of OA. Show that the exact line of BC. Oh, sorry. I'm so sorry about that. The exact line of BC right here is this expression. Right. So as you can see that this is a triangle, right? Right here. This is the triangle. We know the angle when we know 2 sides adjacent to the angle. We can use the cosine rule for this. Agree? Right. So if you don't remember the cosine rule, it's okay. It should be right here, right? Is it?
Yeah.
Is it right here? Let's see. What page is it?
Go to the Second page? It's near the top, I think.
These are trigonometric identities. Oh god, there's
Oh,
none.
it's not here.
Oh god, there's none.
Okay, so this is something you'll have to... Do you remember it,
Alright,
Devan?
then. I'll just write it down if you don't remember. We have a squared is equal to b squared plus c squared minus 2bc cosine of the angle A. In this case, our A is right here. I'll just write it down. A is right here. This is our B and C. Doesn't matter if you want to put this as B or this one as C. They're both the same. And our angle A is right here. Agree?
Yep.
Right. So we can look for what BC is. Let's say BC squared is the same as 2r squared plus r squared minus... Just basically plug everything in and solve it. Cosine of pi over 6. Right. So let's simplify this more. 4r squared plus r squared, that's 5r squared. Minus 4r squared. What's
4r
cosine of
squared?
pi over 6? Root 3 over 2.
Root of 3 over 2.
Okay. Simplify this a bit more. So 5r squared. The 4 becomes 2. We have 2 root 3r squared. Square it both sides. Everything looking good so far? All right. So from here, we can factorize the r square. We can factorize the r square right here. Right? And by the rules of exponentiation, remember that square root is just power 1/2. We can just split the 2 as long as they're multiplication. Like this. Agree?
Yep.
Right. So we can split it, and we have square root of r squared and whatever's left here. But square root of r squared is just r squared. So just erase that. And we're done. Very simple, right? Very simple, right? Am I
Devan,
lagging?
you're
Hello?
frozen.
Oh, I'm frozen again.
And your voice is lagging.
Still?
Hello?
Yes, hello.
Yeah, the stream is frozen. Can you see?
I cannot see.
Oh, no,
because
it's
it's
back.
from me.
Okay, you're back.
Oh, okay. So everything okay? Is my screen okay?
Now you're frozen again.
I'll restart.
Are you moving? Okay. That might be a bit better. We'll be back shortly, you guys.
Hey, hello. Can
Hello.
you hear me?
Yeah. Your video's fine. The stream is fine.
Okay.
Can you move?
Yep. So everything
All right,
okay?
there.
Right
Yeah,
here?
it's fine.
All right. Let's move on to the next question. Find the exact perimeter of the shaded region. Sure. So this is the shaded region, of course. Let me just erase my highlights. So of course this is the shaded region right here, and we already know this part. We know what BC is. We already know what AC is. We just have to look for what BA is, right? So how do we find BA? What's BA?
We can notice that OAB is a sector, so we can use the line sector formula, which is S is R theta.
Exactly. So to find AB, that would basically mean R theta, right? Because it's an arc circle. And if you forget, it's just right here in the formula sheet. It even includes the area, so that's good.
Can't believe that's in the formula sheet, but the cosine rule is not.
I know, right? Like, why?
If anyone does find it, please tell us. Okay, we can go back to the...
All right. So remember that our radius is 2r, and our angle is pi over 6. That means AB is just 2r times pi over 6. Just pi by 3r. Agree? All right. We've got everything. We've got BC, we got AC, we got AB. Now we just have to add them all. Right. So the perimeter is R from the last question plus R plus pi over 3r. Agree? You can just factor the r if you want. You can factor it out. 5 minus 3 plus 1 plus pi by 3. And that's it. You just have to, because they ask for exact, you don't have to put this in your calculator. That's your answer.
Yeah.
Right. 2 marks. They're giving so much space for 2 marks, but it's okay. Just be thankful for it. Find the exact area of the shaded region. Sure, why not? We can do that. So, as you can see here, that this is a sector of a circle. We can get the whole sector of the circle, correct? Then we subtract it by the small triangle here, the unshaded triangle. Right? All right. So, to get the area of the sector, just take a look at the formula sheet again, and it's just right here. All right, so we have the sector minus triangle. Right, so the sector is just half. The formula for the sector is just half theta r square. And our triangle, it would be much easier if we use this formula for the triangle, right? Because we know both sides, both adjacent length with the relative to the angle. All right. So let me write that down there. AB sine C. All right. So we have half. Just plug in everything basically. Pi over 6, not 0, 2r squared minus half r 2r sine of pi over 6. Everything correct so far?
Yep. Okay,
let's simplify this a bit more. We have 4r squared, 4 divided by 12, that's 1/3. 1/3 pi r squared minus the half here cancels with the 2. R squared sine pi by 6.
That's half.
Half. So it's half. Then we can factor out the r. So 1/3 pi minus half r squared. Okay, done. Because we're looking for the exact area, you don't have to put it in your calculator.
Yep.
Okay, box your answer and run away. Next question. The diagram shows a part of the curve y is equal to 6 over x. The points 1, 6, 3, 2 lies on the curve. The shaded region is bounded by the curve, and the lines y is equal to 2, and y is equal to 2 is like this, and x is equal to 1. The volume generated when the shaded region is rotated. Oh, find the volume of the volume generated when the shaded region is rotated through 360 degrees on the y-axis. So the y-axis means that you rotate this way, right? Like that. Okay. Whew. First of all, let's the pop-up again.
Pop-up.
I realized. Let's recall what's the formula to find the volume when you rotate it in the y-axis. Of course, we have to use the integral. We have the integral multiplied by pi x squared dy, correct? This is if it's the y-axis. If it's in the x-axis, that will be pi y squared dx. But we're not going to use that now because it's y-axis. All right. So, right. So first of all, we need to make x the subject here, right? This shouldn't be so hard. We just have to cross multiply, and we have 6 over y, correct? But the problem is if we integrate this, we'll also get this area right here. So
Mm.
we have to subtract it, correct?
Mm-hmm.
All right. So that means we have the integral going from, remember this is in the y direction, so we have to take the y values, which is 2 and 6. We have 2 to 6 of pi 6 over y squared. Not x, that wasn't an x, sorry. Minus pi over, remember that the x-axis, this is basically when x is 1, right?
Mm.
Therefore, we have 1 squared dy. Let me just erase this. Okay. So, sometimes I've seen some mistakes that some people would do this, and this is completely wrong. It's very different
Ooh.
from this one. So I've seen
Mm-hmm.
some students did this. So I just want to make sure that you don't do this because this is completely wrong. Am I right, Yugan?
Mm-hmm.
All right. So just a warning, so that you don't make any mistakes like this, because that is not the right way to do it. Okay, let's do the question now. Let's simplify everything. We have integral from 2 to 6. 6 over y squared, that's 36 pi over y minus pi dy. Oh, sorry, y squared. Right, let's integrate this
Mm.
normally. I think I want to bring out the pi so it's much easier. You can just factor the pi out. 36, 1, and pi. Okay, so let's integrate this one by one. What's the antiderivative of 36 over y squared?
So we would get negative 1 over y, right?
Yep. So we have negative 36 over y. The reason is that when you integrate y minus 2, you'd get y to the minus 1 over negative 1.
Mm.
Right. So that then you just have to multiply by 36. Okay. The integral of 1, that's just y, because y to the power of 0 plus 1, y to the power of 1.
Mm.
All right. We have this expression now, and let's evaluate it. We evaluate when y is 6 and when y is 2. We can do that, of course. 3 over 6 minus 6. I'll make a big bracket here. Negative 36 over 2 minus 2. Can you put in a calculator here for me?
Okay, give me a sec. Negative 36 over 6
Mm-hmm.
minus 6, and then that all minus. So it's just plus 36 over 2 plus 2, and that will get you 8.
8. So it's just 8 pi. Wow. Very nice answer. Thank you to the examiner. Next question. 5 marks, very easy. The tangent to the curve at a point x is parallel to the line y plus 2x is equal to 0. Show that x lies on the line y is equal to 2x. Sure, why not? All right. So basically, in the curve, there is a point x. Let's say I don't know where x is. Maybe x is right here. Maybe this is x. Such that the tangent, let's say this is the tangent right here, is parallel to y plus 2x is equal to 0.
Mm.
It's parallel to this. That means the gradient has to be negative 2. Because just put in your side, you have a negative 2 gradient right here. Okay, so let's go back here. That means we have to find where in the curve is the gradient is negative 2, right?
Mm.
Is that right again? All right, so we have what? We have our equation. Just have to differentiate it then, dy dx, because when we differentiate, we'll get the gradient.
Mm-hmm.
And remember that when you differentiate 1 over x, so just to recall, 1 over x is just x power minus 1. It's basically just negative 1 x minus 1, which is just minus 2. So we have negative x minus 2, and like that. Multiply by 6, and you have this. Agree?
Yep.
Right. We just have to look for when is this equal to 2. That means you have to equate it to 2. Wait, so -2. Sorry. -2.
Yeah.
My bad. We make mistakes too sometimes. We're humans. You just have to solve the equation then. So 6 divided by 3, that's 3 is equal to x squared. X is equal to √3.
True.
Do we have to take the square root?
No, because
Why?
we're just looking at the line shown in the graph, right?
Yep. Therefore,
Mm.
because the line in the graph is positive, it's on the positive axis right here. We don't care about anything negative. No, if you know right, negative square root of 3, it's fine. But it's not like they need it, so it's okay. Right. So show that x lies on the line y is equal to 2x. Sure. So we found the x coordinate of big capital X. We just have to find the y coordinate. So let's do that. Y is equal to 6 over putting our x value right here. This is 2√3. All right. That means x is at, the capital X is at √3, comma, 2√3. That's our coordinate. Is this in the line y is equal to 2x?
Yeah, we can notice that the if x is the root of 3, then if we just multiply it by 2, it's obviously 2 root of 3. So it lies on the line.
Okay. So there you go. Just box the answer, and we're done. Agree? All right. 3 marks for you. Just be grateful for it. Right, next question. Functions f and g are such that fx is 2 minus 3x sine 2x. Gx is -2 f of x. Sure, okay. State the ranges of f and g. All right. So for a sine wave, remember a sine wave, a normal sine wave. Let's ignore this first. A normal sine wave can only go from -1 to 1. Agree? Then we multiply it by -3. So it goes from -3 to 3. Right. So let me write it from -1 to 1. Because we multiply it by -3, we go from -3 to 3. But we add 2 to it. So that means the whole thing will move up by 2.
Yep.
So I have to add 2 to the range. So -1, y, and 5. Right? Therefore, the range of f is just this. Very simple. All right. Now what about g? G is just -2 of this. Just multiply it by -2. -2 times 5 is just -10. Instead of becoming the maximum, because you multiply by negative, it goes down. Like it goes down. Therefore, it becomes the minimum. Same thing for the -1. It was negative, it was the minimum, but thanks to the -2, it goes up. It becomes the maximum. We have gx less than 2.
Pop up.
Oh, sorry. So, agree? All right.
Also, to any of the viewers wondering, we are taking the full range of sine 2x because we're looking at the domain between 0 and pi, and that is the full domain for one wave of sine 2x. If it was just x, you would take half the wave.
Oh, yeah, exactly. I forgot to mention about it. Thank you.
No problem.
So, what Yugen said was correct. Forgot to mention that. Thank you, Yugen. Right, next question. The diagram below shows the graph of y is equal to f of x. Sketch on this diagram the graph of y is equal to g of x. Right, sure. So remember that g of x is just -2 times f of x. First of all, this has to go down because you multiply with -2. It should become
Mm.
negative. Second, the zeros will stay because -2 times 0 is just 0.
Mm-hmm.
Right? Therefore, let me try to draw it. It should start from here, maybe about there. It should pass the zeros. I'm sorry, I'm really bad at drawing. And this one will also get scaled, but downwards. Right?
Mm.
Let me draw
To
it.
have a more accurate drawing, it should pass double the x coordinate of f of x.
Mhm. Right, that's the best I can do. Sorry.
Your first
Okay.
stationary point should be higher.
Oh, sorry. What?
It should be higher, right? Should it
Yeah,
be?
higher. There, I made it higher.
Okay, yeah, yeah.
Oh god, oh god, oh god. Right, like that. I tried my best. I think
Yeah,
you
that's right, that's right.
okay. Right. The function h is such that h of x is gx plus phi. Describe fully a sequence of transformation that maps the curve f of x into h of x. Basically asking, how do you make f of x into h of x? Right?
Mm.
First, let's start from hx. So from the question, it says hx is g of x plus phi. But what is g of x plus phi in terms of f of x?
That would be -2 f of x
Exactly,
plus
yeah.
pi.
Plus. So because g of x was -2 fx, just
Mhm.
replace the x with x plus phi, and we get this. Agree?
Mhm.
Right. So how do I go from here to here? What do you think?
Ooh. So f of x to h of x.
Hmm.
So we would have to enlarge the sine graph by a scale factor of two, right?
So scale by -2 or 2? I don't know. I think it's better to say -2.
If you scale by -2, don't you? Yeah, scale by -2.
And what's next?
And then we have to shift the graph backwards, right?
Exactly.
By quarter phase.
That means we have
So,
to translate, right? Translate
mhm.
to the left by pi units. Left, well, in the the what do you call it? X-axis. Left is basically
Mm.
backwards. Backwards is left, right?
I think you should write it as a vector for it to be more clear
A
as an
vector.
answer, right?
I guess translate
Yeah.
by translate. Okay, then I can just write translation -pi 0.
It's 0 -pi because it's in the right.
But I thought it's in the x-axis, so it should be like that, right? Is it not? Wait, x in the x direction. That means it should be in the top, right?
Hmm. In the x. Yeah. Okay.
Yeah, should be like this.
All
All
right.
right.
All right.
No
And
need to
the
box the answer.
scale
Just
by
go answer.
and the
Sorry.
scale by -2. That's a bit vague. If you guys want to be more exact, you can write reflection in the x-axis and then stretch by a scale factor of 2.
Oh, yeah. That makes sense. That makes sense. Okay.
So I think you might lose
So
marks if you write scale by -2.
sorry.
You might lose marks if you write scale by -2 because
Mhm.
that's vague.
Oh, okay. So I'll just remove the negative there. All right. So thank you for that.
And
And
reflect the x-axis, else that's also wrong.
sorry.
reflect in the x-axis,
Oh, reflecting the
and
x-axis.
then stretch by 2. Yeah.
Where do I write it? Reflect in x-axis. Okay. Is it okay now?
Mm-hmm.
Okay. Thank you for that. Now let's move on. Any more to add, by the way, before we move on?
No,
Okay.
that's it.
Let's move on then. The equation of a curve is y is equal to 54x minus 2x minus 7 cubed. Find the first derivative and the second derivative. Sure, why not? No, we'll just do it directly then. Let's find dy dx. That's just 54 minus. So by the chain rule, we have to put the 3 down and multiply by the derivative of the inside. Correct? Right?
Mm.
That would be 2 times 3, 6. And 2x minus 7 squared. Right. For d square y dx squared, we'll do the same thing, but this time the constant dies. Correct?
Mm-hmm.
The constant dies, so we'll just poof. And we have to multiply 2 and 2 again. That'll be negative 24, 2x minus 7. Right?
Yeah.
Agree?
And
Okay, we're done.
Yeah.
This is the whole answer. Thank you, Mr. Examiner. 4 marks. Find the coordinates of each of the stationary points on the curve. That means you just have to equate dy dx to 0. Okay, so we just have to dy dx is equal to 0. Let's put everything here. 54 minus 6, 2x minus 7 squared is equal to 0. Let's bring this to the other side. 54, 6, 2x minus 7 squared. Can we divide by 6 both sides?
Yeah, you get 9.
9. Wow, such a nice number. Thank you. We just have to square both sides then. We have 2x minus 7 plus minus 3. Don't forget about plus minus when you square it. Right. So we have 2 possibilities. Either 7 plus 3, which is 10, or 7 minus 3, that is 4. Just have to divide both sides then. We have x is equal to 5 or x is equal to 2.
Mm-hmm.
But we're not done yet. I feel like I'm writing too large. I'm sorry about that, guys. Because we want to look for the stationary point, you can just put the x values in your calculator and put it here. Can you help me do that?
So 54x minus. Could you go back to the equation, Devan?
Right here.
2x
So
minus 7 cubed, right? So
there.
we can calculate it when it's 2. That's 135.
135.
And when it's 5, it's 243.
243. 3 to the power 5. Okay. That we just have to write it down then. We have 2, 135 and 5, 243. Okay. Box the answer. Are we done with the question?
Yeah, that's it.
Okay. Move on. Determine the nature of each stationary point.
Up.
Oh, sorry. I hope I'm not annoying. All right. If you want to determine the nature of the stationary point, we would have to use the second derivative, right?
Mm-hmm.
And we already have that. We have the second derivative right here. We just have to put the x coordinate, correct? Then, okay, so let me just write the second derivative again. Is negative 24 to x minus 7. All right. Let's put when x is equal to 5. 5, 2, 4, 3. Can you put this in your calculator? Help me.
When you put 5, you get negative 772.
Negative 72. Because it's less than 0, that is a maximum. Right? So the second derivative determines the nature. If it is less than 0, that's maximum. If it's greater than 0, then it's a minimum. Correct?
Mm.
All right. So let's find the other one. Let's find it when it's 2,135. What's this equal to? 72, is it?
That's positive 72, yeah.
Yeah, that means it's a minimum. All right. And then, thank you. 2 marks. Easy. Right. Next question. The equation of a circle with center C is x squared plus y squared minus 8x plus 4 minus 5 is equal to 0. Yeah, I can laugh. Find the radius of the circle and the coordinates of C. Sure. So remember that if we want to find the radius and the coordinates of the center, our equation has to be in this form.
Mm-hmm.
Right?
Mm-hmm.
But it's not so convenient because our examiner gave it this way. So we have to convert it into this form. Right. So let's do that. So how can you convert it?
We can complete the square.
Exactly. We can do that. So let's collect the terms, the x and y terms together, and we can complete the square. So just like before, we'll divide 2 on the coefficient of x. We have minus 4. Then you have to minus by the square of negative 4, which is 16.
16.
Same for y squared. We have y plus 2. 2 because it's 4 divided by 2.
Mm-hmm.
Minus 2 squared, which is 4. Minus 5. Yep, like that. And we just have to move all the constants to the other side. So we have x minus 4 squared plus y plus squared 25. 16 plus 4 plus 5 is 25, right?
Yep.
Okay. Good to know. Right. But before we state the radius, 25 is not the radius. Because remember, it has to be in r square form. But thankfully, 25 is just 5 squared, right? Therefore, our radius is 5. But our center is not negative 4 and 2. Some people will write negative 4 and 2, and that is completely wrong. The correct one would be 4 and negative 2. You have to take the negative of these constants. Agree?
Yep.
All right, and that's it. This is our final answer?
Yep.
Okay, you just box the answer. Thank you. Right, next one. The point P1, 2 lies on the circle. Show that the equation of the tangent to the circle at P is 4y is equal to 3x plus 5. We can do that, right? The equation of the tangent of the circle is 4y is equal to 3x plus 5. Sure, why not? Right, how would you solve this one, Yukan?
You can put the point P into the tangent equation, right? And you should be able to get the same coordinate. So that's to show that it intersects.
Put P here. You want to put P here or what?
Yeah.
All right. So when we put P there, that means 4 times 2 is equal to 3 of 1 plus 5. We have 8 is equal to 8. Check. P is really in here. So what would you do here? Have any idea?
We also have to show that the gradient is the same. The gradient at Pn.
How can we do that?
So we can rearrange P to find y, to make y the subject.
So we have 3 over 4x plus 5 over 4. Is that what you're saying?
Mm-hmm.
So you have the gradient as 3 over 4. Okay, that's nice.
Mm-hmm.
Now what?
And for the circle, I'm not.
Not quite sure. Are you?
Yeah, I'm not quite sure. I know we can use implicit, but that's not in P1.
That's not in P1. I think I know how to do that. Let me show you.
All right, all
Let's
right.
draw the let's draw the circle first to make things clear. See, perfect circle. I'm very good at drawing.
Mm.
Now this is our tangent. This is our P right here. P. I'll use a smaller font. P1, 2, and this is our center. C. And for okay. So here's the deal. We can use this line here to help us.
Mm.
What's the gradient of P of this line?
That's the change in y per change in x.
That is M of PC, which is 2 minus 2. 2 minus 2. And 1 minus 4. Correct?
Mm.
Right. Which is negative 4 over 3, right?
Yep.
Okay. Now, this is the gradient of this line here. The M is just negative 4 over 3. But we know that the tangent and the radius is perpendicular.
Mm-hmm.
Therefore, by using
Mm.
this formula, the perpendicular formula,
Mm.
we can say that the other gradient is 3 over 4, correct?
Yep.
Now, let's use this formula. Y is equal to mx minus x1 plus y1. So what's x1 and y1 again?
We can just use the point 1 and 2.
Exactly.
So
So y
x1 is
is
1.
3 over 4, x minus 1 plus 2, right?
Mm-hmm.
Then we can just expand it. Actually, I'm just going to multiply 4 by in both sides. We have 4y, so do 3x minus 3 plus 2.
You have to
Oh,
multiply 2 by 4 as well.
whoops. I'm sorry.
2 times
3.
4 is 8.
My mental math is so bad right now. Right. And we have 3x plus 5. And there you have it. Shown. That's how you do it.
All right.
It's kind of tricky. I
Should I-
actually kind of have a hard time when I first did this. Actually, honestly.
Oh, okay.
But that's
Yeah,
how you
I
do it.
thought we could just use implicit, and then I forgot this is P1.
This is P1. You cannot do that. That's illegal. Right. Next question. The point Q also lies on the circle, and PQ is parallel to the x-axis. Let's draw the circle again.
Q? Okay.
So we have P right here. Q also lies in the circle, and the line PQ is parallel to the x-axis. That means the line. Let's draw a line parallel to the x-axis. Therefore, Q has to be right here. Correct? Is that right?
Mm.
That means, because we know the coordinates of P. What's the coordinates of P again? That's 1, 2, right?
Devon, you're
1.
cutting out.
Oh, sorry. Still cutting up. Still. Hello. Hello.
Mm-hmm.
Am I okay?
Just a little bit, yeah.
Is it?
Your
Oh,
video.
God.
Oh, okay. Yeah, you're fine now. And pop
Am I
up.
okay now? Wait. Let me restart just to be sure.
Oh yeah, you're still. All right, all right. We'll be back shortly, you guys.
Hello. Okay. Thank you.
Welcome back.
Right. So because am I fine? Is it fine?
Oh yeah, you're fine. You're fine.
Okay. So since PQ is parallel to the x-axis. Therefore, I can just draw a line that's parallel to the x-axis, and we can find where Q is. And remember that.
Mm.
And remember that the coordinates of P is 1, 2. Therefore, this line right here is just y is equal to 2, right?
Mm.
So how do we find Q? What do you think? How can
So
find
we
Q?
know that the y coordinate is the same, so we can just plug that y into our circle equation to get the two values of x. One of them should be 1, and the other one would be your q coordinate.
Exactly. So let's do that. Let's use this one right here. So we have x minus 4 squared plus 2 plus 2 squared and 25. Right.
Mm.
So let's solve that. Square 25 minus 4, that's... Wait.
Minus 4 squared, that's
no.
9.
It's 9. Sorry, I'm so sorry. My mental math is becoming... Oh my god. Right, we can square it both sides. Don't forget the plus minus. So we have x minus 4 plus minus 3. We have two situations. Either 4 plus 3, which is 7, or 4 minus 3, x is equal to 1. But remember, the x is equal to 1 is just our p right here. So we just don't really care about this one. Now we just have to look for the y value. What's the y value?
The y value is, well, that's just 2.
Yeah, that's just 2. Therefore, our coordinate is just 7, 2. Why 2? Because we use y root 2 here. All right. We're done, right? This is our Q. We're done with this question? Hello, you can?
The
Hello?
stream is frozen, Devan.
Oh, sorry.
And yeah, your video's not working anymore. Alright, we'll be back.
I am back. Haha. Hello? Hello, Yugan?
Devan?
Yes, hello. Can you hear me?
Oh yeah, you're fine now.
Okay. All right. So the tangents to the circle at P and Q meet at T. Is my video okay? Is my voice okay? Hello, Yugan? Hello?
Yeah, hello? Did you say something?
Hello, Yugan?
Hello?
Is my voice okay? Is my video okay?
Hello? Yeah, I can hear. Your video's frozen again.
All right, let me reconnect.
Your video's frozen. Hi. This is the very last part, and Devan cuts out here. Okay.
Why
Yeah.
you gotta be like this, man?
All right. Everything's
Is everything
fine.
okay? My
Yeah,
voice?
everything's okay. Just quickly do this before it happens again.
Okay. The tangents to the circle at P and Q meet at T. Find the coordinates of T. All right. So let's do that. Let's draw the circle again to make things clear. You don't have to, but if you want to, it's nice. Right. So this is our P, this is our Q, this is our T right here. You just have to see where they meet. Right. So we already know the tangent to P from the last question here. We can just copy paste that. 3x plus 5. Now we just have to look for Q. What is the gradient of Q?
The gradient, it's by symmetry, so it should be -3/2, -3/4.
Therefore, so the gradient of Q, the tangent to Q is just -3/4, correct? By
Mhm.
symmetry. So let's find the equation of the line. If -3/4, x minus, remember the x coordinate of Q is 7, then we have to add 2 to it. Let's multiply things by 4. We have 4y minus 3x plus 21. 2 times 4 is 8. Right. I'm sorry. My my brain's not working well. Right.
And you're the expert here.
Hey. Don't be like that.
Yeah, that's your
Don't be like
equation.
that. Right. So we have two equations: 3x plus 5 and 4y negative 3x plus 29. Right.
Mm.
Let's solve for x and y. First, I can add both sides so that I get 8y. The 3x here will cancel. We have 29 plus 5.
Okay.
That's 34.
34.
Y is so 34 divided by 8. Can you simplify this for me?
17/4.
17/4. Thank you. Now let's find the x. To find x, we can subtract the first equation from the second equation. So first minus second equation.
Mhm.
We'll have 0 is 6x. 5 minus 29. That's -24.
-24.
Right. So 6x is 24. Let's just solve for x and we get 4. And that's it, guys.
Mm.
We have both coordinates and we can box the answer and say thank you to the examiner for the 3 marks. And yeah, that's it. That's it. It's just the additional page. Oh, somebody said
Yeah.
you could also say that the x coordinate of P is the center and Q are in AP, so Q must be. Oh yeah, that makes sense. That makes sense. So thank you for the suggestion.
Where is A?
A. Wait. Oh yeah, where's A? Whoops. I'm having brain lag.
I mean, but I get what he's saying. Yeah. The difference
Okay.
from the point to the center, and then you just add that.
Yeah. So thank you for the
That's
question there. And yeah, we're done with the paper. Right? So thank you guys for watching this episode and your outro, Yugan.
Yeah, and of course, that's that for today. I hope all of you enjoyed the session and learned something valuable. Thank you, Devan, for taking your time during this session. Good night, everyone, and stay tuned for our P3 session next time.
Next
Bye bye.
Wednesday. Bye bye. Thank you guys. Bye bye.